All right, let's do the second question in the Neetcode 150 roadmap of arrays and strings. And this is the valid anagram question. Given two strings s and t, return true if the two strings are anagrams of each other, otherwise return false. And it gives us the definition that an anagram is a string that contains the exact same characters as another string, but the order of characters can be different. So just by looking at the question, we can see that we have race car and we have car race. They are of same length in this particular context, and they have like same amount of characters. So there are multiple things to keep in mind in an anagram is they follow some properties. And just by looking at this, we can say that an anagram should always be of the same length, right? Because if it is an anagram, that means they contain same number of characters and same characters. So the length has to be same. The second thing I can say is the characters have to be same. Characters are same in both. So that means two anagrams cannot contain different characters, because otherwise if we jumble them up, they won't match. So if in race car, if I replace E by F, that is no longer an anagram. Although the length is same, but F is not present in T. That means it's not an anagram. We cannot jumble T to make it like S because it contains an F now. So it's not an anagram. The third point to keep in mind is the amount of characters also has to be same. So characters is same. What does this mean is that if we have, let's say, RAC, R is one time, A is one time, and C is one time in RAC. And if I go to T, there is also R is one time in CAR, C is one time, and A is one time. If any of the characters is more than one time, that means it is violating the first priority, which is the same length. If it contains one character more than the previous one, it is violating the first need, which is the same length. After that, it won't be the same length if I add a P or C or E or any same character. So let's say that I have E here and I have an E here. But if I change this, not change it, if I add another E into this, although it does contain the same characters, but the amount of characters is not same anymore, and that violates the first requirement that it has to be of same length. So that is not an anagram. Okay, so I hope you understood what an anagram is. Let's move on to the solution of the question part. And as I said before, that I will go through the naive approach and then we'll build on top of it on how to optimize our particular approach. So we go through the constraints here, and we can see that we have an S and T, which consist of lowercase English letters. In this particular question, this is an easy one, and because of that, we only have English letters. However, there are medium and hard level questions as well, in which we have characters which are not in this context in English letters. We have comma, we have hash, we have colon and all. So if I give you an example, let's say I add a car here and I add a colon here and a comma here. But if I add an RAC here, if I, let's say, make an arc here, this is also another word, and if I add a comma, hash, and they'll ask you to check if these are anagrams or not. They are anagrams by looking at the context, since they are following the same thing, but you will have to make sure for the edge cases in which they contain different amount of characters which are not judged based on this. So there are questions which are medium and hard as well. So we'll solve them probably someday when I'll make another video, if that one is in this roadmap. But so yeah, there are multiple questions in this particular topic as well. But now the time complexity for us given is O of n plus m, and the space is O of 1. But for the naive approach, I'm not going to focus much on this, because my particular goal is to let you know that how we solve these questions just by reading in them. So coming to the first way is just by looking at it, we can naively think of it like, why not we just sort these particular words, and based on the ASCII code of the particular letters, that means we'll be able to sort them and we'll be able to get the same amount of list, let's say the number of characters, and we'll get the same numbers in same sequence, and that means they are sorted. So for example, let's say R has 17, A is 1, C is 3, and if I sort this as well, I will also get 17, 1, and 3. So in that context, I will be able to see, let's say 1, 2, 3, and these are the ASCII codes of them, and the S will be 1, 2, 3, and then T in sorted in ASCII code will also be 1, 2, 3 when we will sort them. So in this way, we'll be able to check if these both are same. So that means they are anagrams and they are same. Now, so how do we sort them in Python? That's very simple. We'll just do s.sort, which is an inbuilt Python function, and we'll do t.sort in the Python function, and we'll just return if t is equal to s or not. So s equals t or not. We'll just return the values, since it says that return true if the strings are anagram, and if they both are same, we will get true, and if they're not same, we will return false. So we'll just directly return the values. And let's run this code, and we got an error. Let's see what the error is. An error is that attribute error str object has no attribute sort. How come? Python has an inbuilt sort function. We know this because if I create a list of, let's say, 3 to 1, and if I do nums.sort, this works. I will show you that this works. So let's do a print num here, and I'll just comment this off, and for now I'll just return false. And if we run this, this works. We got the output 1, 2, 3. So why this thing is not working for strings? Now the reason here is list in Pythons are mutable objects. That means you can change the values of list in Python in place. So if I do a num0 30 here, this will also work for me because lists are mutable objects in Python. You can see here lists are mutable sequences. However, if we go to string types, strings are immutable by design. So when you create a string in Python, you cannot access the values. You cannot modify the string in place. You will have to always return a new string. But this sort function which we used, this works in place. I didn't do nums equals to nums.sort. I just did nums.sort. So this is actually changing my list in place. However, if I do s.sort, this will not work for us because strings are immutable and we are trying to use a function which changes the values in place. So this will not work. So what do we do? Luckily, Python developers who created Python, they thought of this and they created a universal sorted function in which we can send in any iterable and it will return us a new sorted iterable based on some condition without changing the actual value sent. So what I'm telling you here is we have different sorting techniques here, and one of them is sorted function there. So it returns a new sorted list from an items in iterable. So this you have to always keep in mind that the sorted function actually returns a sorted list. It will always return a list regardless of any iterable you send. So if you send in a tuple, if you send in a dictionary, if you send in a string, it will always return you a new list. So you always have to keep this in mind. Now, if I go ahead and I do, let's say s1 equals to sorted s, and I do a t1 here is equal to sorted t, let's see what happens now. Let's run this code and let's check if this is working. Oh, we were able to sort the values. We did a sorted s, which is referencing it s1, and okay, we have to compare s1 equals to t1. My mistake. Let's run this again, and this got accepted. So s and t are now sorted in s1 and st, and we are now just returning if s1 equals to st. However, as I said, this actually returns us a list and not a string. So as I said, the inbuilt sorted function always returns a new list from an iterable, which is the case here, and it is returning AACCEERR based on the S. So we are actually here comparing the lists, not the strings here. This has to be kept in mind. Now if I type in print ID of S1 and ID of T1, so ID will just give us a reference to where the object reference ID, and here you can see these are two different objects. So the sorted function here returned us two different lists, although they are same in this context, because after sorting them you will get the same thing. However, it returned us two different lists and it is working. So it is checking value based on the value, so it is iterating through A, B, C, D, E, R, R, and then it is returning if these are true or not. So we were able to solve this question by just using an inbuilt sorted function, and if I submit this, it should be giving us that it got accepted. However, this is not really a good approach here. Why? Coming to the time constraint which we were given O of n plus m time constraint. So did we use an O of n plus m? We didn't. Why? Because sorting in Python takes O of n log n, and in this case the n is the length of the string s, and here we are taking m log m, which is the length of the string t. Now obviously this is greater than big O of n, and this is greater than big O of n, right? So what do we do? Although the question is solved for us, but it's a good idea to try to follow it based on the constraints which we are given. So in this case, S1 and T1 are sorted lists, and we are just returning if they are true or not. However, this is not really a good approach because it's taking more time than it should be. So imagine if we got, let's say, 10 raised to the power 7, 10 raised to the power 8 number of characters in both of them, and then we will sort them in n of log n time, and then m of log n time. That will be a huge time taking, and also it is taking off extra space as well, because we are returning a new variable, not we are not changing them in place. We are actually returning a new list. So the amount of space that list will take is humongous, and that is definitely not an O of one space. That will actually be a space complexity of this particular thing will be O of m plus n. Why? Because both of them are lists, and based on the amount of length of characters that we have, both of them will contain some m characters and n characters. So that way two lists will have the space complexity of O of m plus n. However, we are supposed to give O of one space. This is accepted, but it's a good idea for us to think about it and iterate through back that what we can change to see if this particular question can be solved in a more optimized way. Now, coming to the second approach, the second thing that comes in our mind is we can actually just go ahead and count the number of characters that both of the strings have. And if the number of characters and their count is the same, we will just return true. So what I'm trying to say here is we iterate through the list. So let's say for C in S, which is the first string, we just count the number of characters. So let's say if I create a dictionary here, so let's say counter dictionary, which is dictionary, and if C, this is S, if C not in S, that means if this particular character which we are iterating, so I'll just print this off. So iterating C for now, right? And if I do a, yeah, so in this case we are iterating through C, and if C is not in S, that means that particular character has not yet come into the counter. We'll just say counter C equals to 1. So we just add the first character of that, and else if it is already present, we'll just increase the counter by 1. And in this way we are actually counting all the numbers and the characters and the amount of time they have come here. So if I go ahead and do a print C, and I'll just return false here for now because it will give us an error. If I didn't, we'll just print counter. So if I run this, keyword error R, okay, that's weird. What did I do wrong? Key error R. Oh, okay. If C not in S, counter C equals to 1, else counter C plus 1. Oh, we have to check if it's present in the dictionary, not the string. So we'll have to check that in dictionary, not the string. So here you can see we iterated with R first, then A, then C, then E, C, A, R, and then we just incremented the counter and we just saved the number of counts that both of them have. Now what we can do is we can just iterate through T again and then just go ahead and add them into another dictionary as well. So for example, if I iterate through this again using T, we'll get another counter. However, there is a better way of doing this. You don't have to iterate through the letters and store them in a counter dictionary and such like that. We actually have an inbuilt function which helps us to do the exact same thing. So we'll just do that from which is in the collections module, and we'll import counter. So if I go ahead and check here for, let's say, Python collections docs, and if I go to here, and you can see we have a class which is a counter class. So you can see here it just gives us a new counter by counting the number of letters or any iterable thing it has. So counter is a dict subclass for hashing table. It is a collection where elements are stored as dictionary keys and their counts are stored as dictionary values. So we'll just import counter from here, and we don't have to do all this manual approach. What we can do is we'll just take C1 and we'll just print in counter and just send an S. And if I print C1, what we will get is the exact same dictionary which we created early on. So you can see here, this is a counter object which is returning is a dictionary, which is the exact same dictionary which we created early on. So if I go to C2 and I do counter T, so this will give us the count of the characters which are present in T. And now what will I do is I'll just return if the C1.values, so this will return as a list equals to C2.values. So basically what we are trying to say here is we just return, I'll actually show you that. So if I'll go and type this will return us the values. So if I have a dictionary, let's say of K is 3 times, so the dot values will return me 2, and if I have multiple of them, it will return us all the values present in that particular dictionary. So if I run this, hopefully it should work. And as you can see, it has given us dict values which are 2, 2, 2, and 1. And currently this is giving us a wrong answer for false, but the output is true. The reason here is these particular values may not be in the same order. So since R here is, however the letters have coming, they are stored in the same position. They're not being sorted as such. So these values are not the same. Although the value inside the list is same, the order is not the same. The same case is here, that the sorted list, we are not actually sorting them, we're just returning the values. So that's not how we can do this. Okay, so now we have the two dictionaries. C1 contains the counters for S, and the C2 contains the counter for the characters present in T. So we'll just do a print 1 and print C2, and we'll check what sort of dictionaries it has created for us. Yeah, none. Yeah, okay. We'll have to return something here. So for now, I'll just return false, and we'll check again, and we'll see if, so yeah, you can see now we have got two dictionaries. One is for S and the other one is for T. And you can see here R is 2 times, and here is also R 2 times, C is 2 times, C is also 2 times. And for the second case, we have J equals 1, J equals 1, A equals 1, A equals 1, but R here is 1 and M here is 1. So the keys here are not matching, and this returns, and this violates the second rule, which is the characters are same in both. So this should return as false. And although since I'm returning false, this case is working. Now we have got the two dictionaries and we have got the counters of the characters. So we simply return C1 equals to C2. Now what this will do is it will check if both the dictionaries which we have created are same or not. So if I run this, I should get okay, this sometimes creates issues in running. Yeah, so we have got case 1 and case 2. So we added both the dictionaries, and if I submit this now, it should be accepted. Yeah, so we can see this is accepted. However, the space again we are taking here is O of m plus n, because we are creating two dictionaries. One is of m length and another is for n length. However, the previous runtime which we were doing in this thing by sorting them has reduced. So for this particular case, the runtime is now shifted from O of n log n. Since we are not sorting them, it has become O of m plus n. So we were able to run the solution of n plus n. However, the space currently is still O of m plus n. So coming to the second part here now, the space is m plus n and the runtime is m plus n. So we were able to get to the runtime of m plus n, since we are only iterating both of the string once, one n times and another one s times. Oh, sorry, m times. So this is n, this is m. So the runtime is m plus n. This will be O of n. And the space here is still O of m plus n because we're using two dictionaries. However, you don't have to use two dictionaries. Let's try to solve it in O1 of space. Let's say I have only one dictionary here. I just create a one dictionary, which is C1, right? And now by going through the first counter, if I do a print C1, I just iterate through the second one and I will check if that key is present or not, right? And what will happen here is I will see that I have in R2, A2, C2, E1, right? And this is the current dictionary which we have for S. However, we don't have to create a dictionary for T as well. Why? Because if it is an anagram, what we will do, we will just subtract that particular key from the C1 dictionary. So that means it will become 0, right? That particularly means that if C is one time, C here is two times. Let's say, I'll show you here. The C here is two times, right? And when I will iterate through the characters in T1, I will check if the C is present or not. The first rule is that the characters should be same. So the first condition which we will check if is for char in T. That particularly means that for every character which is present in T, if char not in C1, which means it is not an anagram, it is violating the second rule, the characters are same. That means the T contains a character which is not present in S. So from here we can directly return false, since the character which is present in T is not in S and it's not a valid anagram. However, if that particular character is present, what we will do is we will just subtract that from 2. So what will happen is for race car, and if I go through C, this will become 1. Then I go through A, this will become 1. I'll subtract it. I'll go through R 2 times and I'll subtract R 2 times here. So R will become 0. And then I again went through A. A is 1 now and it will become 0 now again. And the C here, I'll go again C, which is C1 now. Since we deleted 1 from here, this will become 0. And for E as well, this becomes 0. Since this is only once, this becomes 0. So we have now got the intuition of we can just subtract the characters and make them 0, right? So if the particular character is present, what we will do is we'll just simply go to that particular value and we'll just subtract 1 from it. And that's it. We have iterated through all of them and we have returned the false if the character is not in C1. This directly violates the second rule, and else if it is present, we'll just subtract it. Now we again iterate through the dictionary. Now our ideal case should be, if they are anagrams, all the keys should be 0. So if they are anagrams, all the values should be 0, since we subtracted from all of them. So what we have to do is, for values, for v in c1.values, if v is greater than 0, that means that particular value was present more than once, more than the number of amount it was present in S. So for example, if in our case E was present here 2 times, but in T it is only present once, so this will not become 0, because when we'll subtract 1 from 2, it will 1, and that's it. E will be left 1. We will just directly return false, because it is violating the third rule, which is the amount of characters is same. So the amount is not the same. That's why we return false. Or if we iterate through all of the values, and this iteration is complete, so that means all of them are 0, obviously. Or to make it more better, we can just do not 0. So there is a chance that some character might be present more amount of times than the present in the previous one, so it may go -1 as well. So we have to check for negative values as well. So I think this is a better way. If v is not equal to 0, we directly return false. That means either the character is present more times or less times than that. If this iteration goes through, that means none of the values are greater than 0 or less than 0, all of them are 0, that means they're anagrams, and we will just return true. So okay, built-in function. Oh yeah, I'll have to add a parenthesis here since it's a function. Hopefully this should give us correct output. Yep. So the case 1 and case 2. See, we are returning true, and this is also returning false. So let's check. And voila, it worked. The solution is accepted. And the beauty of this thing is we are just using O of 1 space. Why? Because we're using a single dictionary, which is of length m, which is a constant, or it can be of length n, which is a constant. So it becomes O of m or O of n, which is constant, which becomes 1. So we have solved this challenge in space of O of 1 and in time complexity of O of m plus n, right? And these were the main requirements of the question, O of m plus n and O of 1. So this is how we solve the anagram question. I know the video might have been quite long, but I wanted to go through the approach, what we basically follow from naive approach to going through the constraints and trying to optimize it further on. I could have directly asked you to just create a dictionary, check if it's there or not, but I have seen a lot of videos, they already do that, but I just wanted to make sure that we go through all the approaches of how to think and how we can optimize the code by first solving it, because it kind of gives us a confidence that yes, we are able to solve the question. The next step is to how to optimize it. And if we go through the hints here, a brute force solution would be sort the given strings and check for their equality. This is the first thing which we did here. We just checked for the sorted ones, which is of log of n plus 1. So this is exactly what I told you. So of n log n, the sorting takes, and which is greater than O of n, obviously. And this solution is acceptable. Can you think of a better way? Yes, we can think of a better way, and we just solved it using the better way. By definition, we rearrange the characters. Does the order of characters matter in both strings? Then what matters? So the order of characters actually does not matter for us, which we saw in this case, because it doesn't matter if the character is at the first, at the second, or at the last. It will just check for the number of count. So the count of the characters and if it is present or not in the particular string is what matters. And if we go to hint 3, we can just consider maintaining the frequency of each character. We can do this by having 2 separate hash tables for 2 strings. Then we can check whether the frequency of each character string is equal to the character which is present in T. We actually did that one in which we created 2 counters, C1 and C2. However, the space constraint was not followed up. and this is using over a space. So we sort of optimize this third hint as well in this, which is asking us to create two separate counters. We were actually able to do it by just one. So hopefully this video might help someone, and I will try to make more videos. We have a lot to follow here. So we have two sum, we have group anagrams, and yeah, this is a good question. And yeah, so I'll try to go through this list as much as I can to, of course, build my logic as well and to share my knowledge with others as well. So thank you so much for watching, and I'll see you in the next one. Bye-bye.